So, anytime that I pull out a common factor of an expression like this, then all I'm going to do is I'm going to make that the coefficient and then state whatever the remainder is inside of the brackets. It's the same as if I multiplied this back out, I'm going to get the original version of what I had. So if that's true, then if I look at the case of 21x and 14y, 21 and 14 have a common factor of 7. There is no variable common factor because there's just one x and one y in the two different terms. And if I look at this, if I divided 21 by 7, I'd be left with 3. And if I divide 14 by 7, I'd be left with 2. So if I expanded this out again and took 7 times 3x plus 2y, it's going to give me this original expression. When I take a look at the second case, well, I have 5, 15, and 5. Those can all be divided by 5. But wait, I got to leave some space because they all have at least 2 x's in them. If I divide 5 by 5, I get the 1 that would be in here. If I divide 15 by 5, I get the 3. And once again, 5 by 5 gives me 1. And then all they've done is, if I had x to the 4 and I took away 2, I'm left with 2. X to the 3 and I took away 2 of them, I'm left with 1. And x to the 2 and I took away both of them, I'm left with no x's in the final term. If that's true, then in this case it tells us what they divided out and they actually just want us to divide it. Well, if I had 5a squared and I divided that by 5a, which is the common factor between these two, then 5 divided by 5 is just 1, and a coefficient of 1 we don't actually need to state. And I had 2 a's, I took away one of the a's, so I'm left with just the 1a left over. In the second one, 25 divided by 5 leaves me with 5, and I took away the only a I had, which means that this is just going to be 5a and a plus 5. For example B, if I had 18p minus 16q, well, 18 divided by 2 gives me 9, and I didn't take away the p, so the p is still there. And negative 16q divided by 2 leaves me with negative 8q. For example C, if I had negative 4mn minus 6m squared, well, if I did negative 2, and I'm dividing that from negative 4, the negative and negative will cancel out and make it positive, and 4 divided by 2 leaves me with 2. I had an m and an n, and I took away the m from there, which means that I'm just going to be left with the n. Negative 6 divided by negative 2 leaves me with positive 3, and m squared, and take away an m, leaves me with an m. And for example D, if I have 18x squared y squared, and I'm dividing it by 9x. Well, 18 divided by 9 is 2. X squared, take away an x, leaves me with 1x, and y squared, I didn't take out any y's, so it's still going to be y squared. For the second one, negative 45 divided by 9 is negative 5. I took away the x, so that's gone, but I still have the y. And 9x divided by 9x, anything divided by itself is always just going to be 1. And yes, if we don't have any variables, we do need to write down the 1. We can't just leave it as blank or say that it disappeared. All right. For example 5, we need to both figure out what the common factor is and divide it out. Well, if I have 20x minus 6, the only number I can divide 20 and 6 by is 2. If I divide 2 from both of these terms, 20x divided by 2 is 10x, and negative 6 divided by 2 is negative 3. For example B, if I have 16x to the 4 and 4x squared, well, 16 and 4 have a common factor of 4. X to the 4 and x squared have a common factor of x squared. So if I divide 16 by 4 in the first one, it leaves me with 4. And if I have x to the 4 and divided by x squared, I'm left with an x squared. And 4x squared divided by 4x squared is just positive 1. For example C, if I took 10, 8, and 2, they're all divisible by 2. I have a to the 3, a to the 1, a to the 1, so I can only take out an a. B squared, b3, and b4, I can take out a b squared from here. So when I divide the first one, 10 divided by 2 leaves me with 5. A to the 3, take away an a, and I'm left with a squareds, and I took away both of the b's. For the second term, 8 divided by 2 is 4. I took away the a, and I took away 2 of the b's. I'm left with 1b. And for the last one, 2 divided by 2 is 1. A take away a is no more a's, and b to the 4 take away b squared. I'm left with just a b squared. For example D, if I have 12, negative 6, and 15, I can divide all those by 3. I have p to the 3, p to the 2, and p to the 1. I can only take away 1p. When I divide that out of the first term, I'm left with 4p squareds. Divide 3p from the second term, and I'm left with negative 2p. And when I divide 3p from the last term, I'm left with a positive 5 and no p's. For example, E, 25, 20, and 30 are all divisible by 5. I have 1x, 2x's, and 4x's, so I can take away one of them. I have 2y's, 4y's, and 2y's. I can take away 2 of them. And I have 3z's, 2z's, and 5z's. I can take away 2 of them. What am I left with? I'm left with 5z minus 4 xy squareds plus 6 x3 y, sorry, not y3, z3. If I put this into problem solving, the surface area of a cone is given by the formula. The area is equal to pi r squared plus pi r s, s being the side length or the slant height coming up the side. Determine the surface area of a cone to the nearest 0.01 centimeters squared, which has a slant height of 7.4 centimeters and a base radius of 2.60 centimeters. Well, what I would do is I would say that the area is equal to pi times 2.60 squared plus pi times 2.60 times 7.40. Now make sure when you're doing this, In your calculator, you're using the actual pi button. Don't put in 3.14. And the area is going to round to 81.68 centimeters squared. Now, if I'm writing the formula in factored form, then the area is equal to pi r squared plus pi r s. Well, they both have a pi in the two terms. They both have at least one r in the two terms. So if I took away a pi and an r from the first term, I'm just left with an r. If I take away a pi and an r in the second term, I'm left with just the s, which means that I could get the same thing by multiplying pi r times r plus s. If I do that, then suddenly the area is equal to pi times 2.60 times 2.60 plus 7.40, and the area still winds up being 81.68 centimeters squared. Which method is simpler to use? It honestly depends on your preference. There isn't a right or wrong answer here. All right, go ahead. Try some practice with the factoring.